Chapter 9, hypothesis, test for one population mean again. Why it is again? Can you remember the title for chapter 8? Confidence interval for one population mean. And sometimes I stated for unknown population mean. Yeah. So it was, chapter 8 was for population mean. Now, another topic for population mean again. So we are going to use the symbol, the Greek letter is mu, because the mu was the symbol for the population mean. Okay, what is the hypothesis test? So chapter 9, we are going to discuss the test. Okay? One day, I ask you my height. How much did you say my height?
6 foot.
Oh, thank you. Oh, yeah. I remember you said 5 and 1. Okay, that is good one. If I consist, my height is 6 feet. How do you think? Is my height is 6 feet?
No.
Why not?
Because you're not 6 feet tall.
Okay, I'm not. I'm not 6 feet. How can you prove?
Measure?
No, we don't have any measures. No. Any idea?
We can see you.
What?
We can see you, so we know you're not 6 feet.
Yes, I'm not. I'm asking you prove.
Oh.
Well, I'm 6 foot. I can stand next to you.
Don't stand up. I know you are 6 feet. Don't stand up. Just a second. You know, even in summer, but it's almost whole semester, 4 weeks, we discuss the statistics, right? Do you have any statistical idea to prove, is actually to test Dr. is not 6 feet? Yesterday, I asked you one by one. He said, I remember you said 5'1", 5'2", 3, 4. Anybody who said 5 and 5? Maybe, but not 5'6", not 6 feet, right? Yeah. How much do you expect the average? You know, yesterday I asked you one by one. That is a sampling, right? That is a sampling. It's a collecting the data, right? So 5, 1, 2, 3, 4, 5. How much do you expect the average? The average of the data, average of your answers. It's probably 5 and 3. 5 and 2 or 3. Does it make sense? The average. The average of your answers. 5, 2, 5, 3. When you compare it to 6 feet, how much is the difference? For example, average is 5'2" compared to 6 feet. You know, 1 foot has 12 inches, right? It's 5'2", 6 feet. How much is the difference? How many inches? 10 inches, thank you. 10 inches. This one. Is it big or small? Is it big? Yes, it is big. It's too big. What does it mean? I lied. I'm not. You know, it will be the hypothesis test. In statistics, I assumed already we had a good sample. And survey. What is the Dr. Arm's height? It's most of you said 5'1", 2, 3. Maybe 4. Somebody need the credit and say 5, right? We are going to take the average. And then compare to the value, the given value. Quite difference? No way, it is not true. Does it make sense, right? 10 inches for height is too much. It's too much. But when I said, oh no, my height is 5'4", even I'm not 5'4", right? But how do you think? 5'4". Average was 5'2". Only 2 inches difference. Still is big, 2 inches. How about 1 inch difference? Yeah, maybe, yeah, okay, yeah, you might be, right? But 10 inches for height? No way, it's too big. But how about this one? When I measure the distance, this classroom and another classroom at Fayetteville, UA, on campus. I mean, another class for statistics on the campus at Fayetteville. How do you think? It's about 1 hour driving, then it's about 80 miles. Yeah, usually we are driving is 70 miles per hour, right? It's a 75 miles, something like that. So when I measure the distance from here to there, is longer than 70 miles, but there is a 10 inches difference. How do you think? It's a big difference or small difference? In that case, 10 inches, small difference. But 10 inches difference for height, quite different, right? So sometimes 10 inches is too big, sometimes 10 inches too small, right? So in that case, as somebody said, your distance and my distance, there is a 10 inches differences, right? It's nothing, it's the same. Statistically, it is the same, right? So based on the idea, we are going to discuss the hypothesis test. So can you expect what we are going to do? So always, we are going to take the sample mean. Do you know why? Please look at the title. It was for population mean. Sample mean was the point estimate for the population mean. Absolutely. In chapter 9, we are going to take the sample mean again. It's good? For the test procedures, I will give you 6 steps. 6 steps. Again, I'm sorry. Yeah, before, when we took the standard deviation, we applied the 6 steps. But in chapter 9, for the hypothesis test, I will give you another 6 steps. The very first step is state the hypothesis. It is a step number 1. The null hypothesis has, the hypothesis has two types. One is the null statement, and the other one is the alternative hypothesis. The null one and alternative one. 2 kinds of hypotheses. Step number 1. So please look at this example. Please read this one. Yeah, it is the pretzel, the package. And it has 454 grams. I mean, that is the mean weight. The mean weight, average, 454. What they want to do? You know, before we want test Dr. Ahm's height is 6 feet. That was the claim. The answer was no, he's not, right? But what is the claim here then? They want to test if it is really 454. Right? I think the package, the snack said the net weight is 450, I think. When it says 450, then the net weight must be at least 450. What does it mean? At least 450. 450 or more, right? It's less than 450, that is a big problem, right? Probably the customers claimed is too small, right? So they want to test if the net weight is really 454 as they expected. That is the claim, right? In this case, we can state the two hypotheses, the null hypothesis and alternative hypothesis in step number 1. The null one, we're using the notation HO. The null means it's nothing, right? It's a basic one, the HO, the null statement. What was this for? For population mean. What was the symbol for the population mean? Greek letter, mu. Always we can state as a mu is equal to something in the null statement, in the null hypothesis. Now we can state unknown population mean is mu is equal to 454. And now we can state alternative hypothesis, HA. Alternative hypothesis. For whom? The population mean again, mu. But now the claim was if it is 454 or not. So now we can state it's not equal to 454. Do you have an idea? I told you always the null statement is equal to, always. Now, alternative hypothesis is mu is not equal to. Then now I can say it is two-tailed. It is a two-tailed test. I will explain to you why it is a two-tailed this later. But we can say it is a two-tailed. We have two more test hypotheses. One will be the left one and the right one. So it's actually we have three kinds of alternative hypotheses. But not equal to, it is two-tailed. And I will explain to you later. It's good? So do you have an idea? How can we state the null hypothesis and alternative hypothesis? Here's another example. In this example, the average retail price of history book was $78.01. What is the claim? You know, it was the price in 2005. We want to know now if it is increased or not. That is a claim. So can you understand what we want to do? We want to test if it increased. Right? I told you the null hypothesis always state mu is equal to still $78.01. How do you think? Alternative one. Before, we just want to test if it is 454 or not. But how about now? We want to test increase. What does it mean, increase? Is going up or going down? It's going up more. So it will be greater than 78.01. Still, the null hypothesis is mu is equal to something. But alternative statement is mu is greater than now. Not equal to, we said it was a two-tailed. But now it's greater than. It is the right-tailed. Again, don't ask me why it is right. I will explain to you later. Not equal to, it was a two-tailed. Greater than, now it is a right-tailed. How do you think? Then what is a left tail? Oh, he's so smart. Less than, yes, less than. Please look at the next example. They recommended RAI calcium, right? It's a calcium. It is very important. Thing for especially women. Okay? So they recommended is 1,000. What is the claim? What is the question? Please read the example carefully, and you should understand what is the claim, what is the question, okay? Most of the time, the claim question is almost at the end, right? So now, there is a claim. How do you think? The null. Always, unknown population mean is mu is equal to what? We want to compare to 1,000, right? And we state the alternative one is mu here and the same value there. And what will be the inequalities? Less than. Why? Why less than? That is the key. Less than. Before, the key was increase. Greater than. Please remind the first example. It didn't have any keys, right? Yeah, safely. Yeah, we can take the two-tailed. It's not equal to. But any key, increase, decrease, less than, more than, better, worse, we have to choose either one, the right one or the left one, greater than or less than. So it should be the less than. So absolutely, it is a left-tailed. So now I can summarize you. Always the null hypothesis is mu is equal to something. You can take the mu zero, the value, from the claim, from the example, from the problem. When you state alternative hypothesis, just copy the mu, the symbol for the population mean, and just copy the value from the null statement And now we have three kinds of inequalities. One is the not equal to, two-tailed, greater than, right-tailed, or less than. Remember, three choices. You have to choose one of them. Carefully read the problem. You have to choose one of them. Two-tailed, right-tailed, left-tailed. It is the step number one to state hypotheses.